Hey everyone, it's Miss B, and in this video we're looking at the Unit 4 Lesson 9 Cumulative Practice Problems for Illustrative Math Algebra 1. So, this was the lesson on comparing graphs. So let's start with question 1, and it looks like we're comparing some graphs. Functions R and D give the height in feet of a toy rocket and a drone t seconds after they are released. Here are the graphs of R for the rocket and D for the drone. Write each statement in function notation. Also, I'm sorry if you can hear some noise in the background. My cat is playing with a toy that makes chicken noises. So if you can hear that, that's what that is. Okay, so write each statement in function notation. That's what we're doing here. At 3 seconds, the toy rocket is higher than the drone. So, okay, the toy rocket is higher than the drone. So we're going to say R, because that represents the toy rocket, of 3. So R of 3 represents the rocket's height at 3 seconds. We're going to say it is greater than the drone's height at 3 seconds. And so both of these are output values. They're not telling us the output values are, but we're telling you specifically when those outputs happen and that one is bigger than the other. And then for B, at the start, the toy rocket is 25 feet above the drone. So when we say at the start, that means 0 seconds. So when 0 seconds have passed, if they were equal, we could say the rocket's height was the same as the drone's. And that would be at 0 seconds, it would be equal to the drone's height at 0 seconds. But this isn't the case. The toy rocket is 25 feet above the drone, so that means the rocket is higher up. So in order to make this actually equal, we need to add 25 feet to the drone's height in order to make them equal. And that's how you would write that. Okay, let's look at question 2. Question 2, A of T is the average temperature in Aspen, Colorado, T months after the start of the year. M of T is the average high temperature in Minneapolis, Minnesota, T months after the start of the year. And temperature is measured in degrees Fahrenheit. So they want to know which function had the higher average rate of change between the beginning of January and the middle of March. So if it's after the start of the year, beginning of January, that is going to be the very beginning right here. And then the middle of March is not quite going to be at 3, because that would be when, if 3 months had passed, so T months after the start of the year, 2, 3, I would say 1. Well, their numbering is a little bit off here, but we're going to look at 3.5. I was just thinking that this should really be 0 and not 1, but the way they have it numbered, it seems to be 1. So either way, we're going to compare from the beginning to about 3.5 right here. And it does appear that around this point they kind of intersect. Not entirely, but they're pretty close to it. So we want to know who has the higher average rate of change. Well, if they end at around the same point, we're going to be comparing this blue graph doesn't have as high of a distance to go from its start to its finish, but our red graph does have a higher amount to go. So that means that our red graph, or Minneapolis, is going to have the higher rate of change. So let's actually write this out. So we decided it was Minneapolis. They're also asking us, what does this mean about the temperature of the two cities? And that's going to mean that just the average temperature increased faster in Minneapolis than it does in Aspen. So let's write that out. Minneapolis had the higher rate of change. And we can say this means the average high temperature we can say rose faster, grew faster, or increased faster. I'm going to say rose because we talk about temperatures rising normally. So that's just my choice of words. Like I said, you can use really any of those three. We're just trying to say it's increasing. So it rose faster in Minneapolis than it did in Aspen from January to the middle of March. Because we want to give all of our context here. January to mid-March. Oops, and March is a month, so we're going to give that a capital letter. I know this isn't English class, but we should still be proper when writing our sentences here. Okay, and that's the front page is just those two questions, so let's move on to the next page. Here we have question 3, and it says, here are two graphs representing functions f and g. Select all statements that are true about functions f and g. So we have A, B, C, and D. A says the function value of f at 0 is greater than the function value of g at 0. Well, if you look all the way to the left, this is -5. We actually are looking at 0. A lot of our graphs start at 0 all the way to the left, so don't be deceived. Now the function of f is this black graph here. The function value here is 0, and I can clearly see that the function of value of g is above it. So this is not true because g is greater at 0 than f is. So we're going to cross that one out. Not that one. Okay, selection B says there are two values of x where f of x is equal to g of x. So this says there's two input values where my graph's outputs are the same. And this is going to mean points of intersection. So I'm going to write that, intersections. And yeah, I do actually see two intersections on my graph because they're not on actual, like the tick marks of my graph. They're not going to be whole numbers, so they're a little difficult to read what the exact numbers are, but this is true. So there are two values where the function values are the same. All right, option C says f of -1 is less than g of -1. So we're going to go to -1 and find f, and then find g. It says f is lower. I would say that is true. So that is correct also. Last one, the function value at -3 of f is greater than the function value of g at 4. So we're actually comparing two different inputs here. So we're looking for, and I'll maybe put little like highlights here. We're looking for the value of f at -3. So let me put a little highlight dot here. And then the value of g at positive 4. And the value of g at positive 4 is right over here. So it's the green one. And yeah, F is definitely higher up. They're still both between 5 and 10, so they're in between those marks on our axes, but F is definitely greater. And that's what this says, is that it's greater, so this is also true. So it is B, C, and D for this question. All right, so that means we're on to question 4. Let me zoom out a little bit and zoom out a little bit and show the whole question here. So let's zoom in now and we'll just do one piece at a time. The 3 graphs represent the progress of 3 runners in a 400-meter race. Solid line represents runner A. So I'm going to put some little notes here. This is A. The dotted line represents runner B. So this looks like runner B. And the dashed line represents runner C. So this is runner C. Okay. One runner ran at a constant rate throughout the race. Which one? So that is actually going to be runner C. Because if you run at a constant speed, your rate of change is constant, which means you're a linear function. So runner C, this one is a linear function. So we're going to say that's equal to constant rate of change. It feels a little counterintuitive to say that the rate of change is constant, because constant and change are kind of opposite words, but it just means that our change is consistent. Okay, a second runner stopped running for a while. Which one? And during which interval of time did that happen? So that is going to be where this person made no progress. And to me, that looks like runner A, because we have this section for runner A that is completely flat. So we're going to say this is runner A. And we can say they stopped between or from. So let's look at the graph first for these numbers. This looks like it's about halfway between 10 and 20, so that looks like it's around 15. And then it looks like right about here is where the curve starts. So that's not quite 45. We can call it 43. So we can say they stopped at 15 seconds and began running again at around we'll say 43 seconds. Could be 42, but you know, we're estimating. Okay. Question 3 says, describe the third runner's race. So that is runner B. That now says be as specific as possible. So let's look more closely at this person's graph. For the most part, it looks like they're going at a pretty steady pace until about here is where I notice that the graph starts to curve. And so it's curving towards becoming flat, which means this person is slowing down. So we're going to compare them to the other people. This person is running slower than runner A, but faster than runner C because their graph is here in the middle. So we'll say, oops, let me zoom into the right place here. Okay, we'll do this part in blue. Runner B ran slow, we'll say faster than runner C. At a constant speed because it was pretty linear right there. For the first, and how many seconds did that look like where they had stopped? It kind of looks like right around here to me. That's like 25, 27 seconds. So let's say for the first 25 to 27 seconds. But then began to slow, we'll say to gradually slow down. And does runner C actually catch them? Yeah, runner C does right here at about 38 seconds. So at around 38 seconds, runner B fell behind runner C. And runner C actually finishes first because runner A stopped. And we can say, and finished in second place. Now, it may seem like I wrote a lot, but they said be as specific as possible. I think I did a pretty good job being specific here. Okay, so question D, or part D here, says who won the race and explain how you know. So we're going to say that if the whole distance here is 400 meters, we want to know who reaches this first. So if we go across, boop, 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 boop. Looks like here it's runner C because then here's runner B and then runner A finally in last. So we can say runner C because they reached 400 meters first. Okay. All right, let's keep going. We have some more problems here. Function A gives the area in square inches of a square with side length of x inches. So complete the table. So a square if we are more accurate about this, my shape was pretty bad here, but a square has all four sides the same. Now area, that is going to be our length times our width. And that is going to be x times x. Or I guess in this case, if we have a side length of 0, 0 times 0 is 0. And with a side length of 1, 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. And 5 times 5 is 25. And 6 times 6 is 36. So that was our first job, which was to complete the table. Now we want to represent it using an equation. That's just identifying what we were doing in order to find each of these things. So I'm going to say that the function value is the side length of x and then squared, which is the same thing as saying x times x, which I mentioned at the very beginning of this problem. And then we're going to sketch a graph of function a. Well, fortunately, they gave us a table, so we're just going to input all of these values on our table and connect it. So 0, 0. 1 and 1 is a little difficult. It's pretty low because this goes by 8s here. But we are going to need to go up to 36. So at 6, we can have 36. It should be right in between 32 and 40. So 2 and 2 is 4, which should be halfway here. 3 and 3 is 9, which should be right above. 4 times 4 is 16. 5 times 5 is 25. Now if we keep going for 7 and 8, 7 times 7 is 49, so just above here. And 8 times 8 is 64, and that's going to be off our graph. So I have this curve, and I'm going to, as best as possible, connect it here. But even then, my tablet doesn't like to give me a good curve, so I'm just going to draw the best one I can, connecting all my dots. And that is my sketch of my graph. So let's keep going, and we'll move on to problem number 6 right here. Function f is represented by f of x equals 5 times the quantity x plus 11. So we read anything in parentheses, or I do. I read it that way. But in general, mathematicians will read it that way as well. We say 5 times because it's implied it's multiplied, and then we say the quantity x plus 11. So find f of -2. That means we're plugging in -2 here. So f of -2 would be if we took all of this and instead said of x, -2 plus 11, and evaluated this. So 11 plus a -2 means this is 9, so we really have 5 times 9. So f of -2 is 45 because 9 times 5 is 45. Okay. And then it wants us for part B to find the value of x such that f of x equals 90 is true. So it wants to know for what input value is my output value of 90 going to happen. So in that case, instead of f of x, we're going to put 90. So when we say f of x equals 5 times x plus 11, we're really saying we want 90 to be equal to 5 times x plus 11. And now we're solving for x. So we can either distribute this 5 or divide both sides by 5. I would rather divide both sides by 5 because then it's a little easier. And this gives us 18 So 90 divided by 5 is 18. And then we would have is equal to x plus 11. So we would subtract 11 from both sides. And that leaves us with x equal to 7. So that is our answer. That's a poor looking polygon there. I wanted that to be a rectangle. Close enough. All right. And that is actually it for this assignment. So there's 6 questions. Just some of them are rather big, or their graphs take up a lot of space. So yeah, that is Unit 4, Lesson 9, the Cumulative Practice Problems for Illustrative Math, Algebra 1.